We're continuing on the previous problem by finding more zeros. One thing I will notice is that my leading coefficient is no longer a 1. There's two different strategies here. Either you remember AC factoring method or some other factoring method. I have one that I like calling the cheating method. It's because it's cheating. It's not really working on the right problem, but it does work every time. Another quite simple, easy thing to do is if you can't factor it, just quickly throw in that quadratic formula. So here A equals 2, B equals -7, and C equals 6. So if you're going to do negative B, x equals, here I'll write down the formula, negative b plus or minus the square root of b squared minus 4ac all over 2a. If all else fails and you forget how to factor these when your leading coefficient's not a 1, and then just use that dang quadratic formula. There's nothing wrong with that, no shame in that. Our calculator handles it well. So here, negative b would actually be a positive 7 because it's a negative 7, plus or minus the square root of -7, make sure you use parentheses, squared, minus 4 times a, which is 2, times c, which is 6, all over 2 times a, which was 2. Now all you have to do is throw this into your calculator. Of course, you're going to have to throw this into your calculator twice, once with the plus, once with the minus. Beautiful thing about our TI-30XS, it will simplify the fraction for us. We can put this all into our calculator in one swoop. If I do this, please do so now. I'm getting the numbers 3/2, 3/2, and 2. So there's my two solutions right there, 3/2 and 2. For those of you who are diehard and want to remember how to do factoring on this problem, let me show you AC factoring method. Always works, well, only works when it's factored. So again, this is A, this is C. So if I did the AC factoring method, what I'm looking for is two numbers that multiply to be A times C, which in this case is 2 times 6, which is 12. So I need two numbers that multiply to be A times C, and then they need to add to be the middle coefficient, which in this case is -12. So two numbers that multiply to be 12, add to be -7. Let's think about what those numbers could be. It's not 12 and 1. It's not 6 and 2. How about a 4 and a 3? A -4 and a -3? Let's see if that works. Yes, -4 times -3 is +12, and -4 times -3 is -7. So those are my two numbers, but what I do is very, very different. Those are not my answers, those are just the numbers. So what I do is I rewrite the equation 2x squared, I keep the plus 6, so I keep the first term, the squared term, and the constant term the same, but now the idea is I'm going to rewrite the middle term, rewrite that -7x, is those two terms. So -7x is mathematically equivalent to -4x minus 3x. So these two things are exactly the same. 2x squared minus 7x plus 6 is the exact same thing as 2x squared minus 4x minus 3x plus 6. Okay? So those are the same thing because minus 4x minus 3x is minus 7x. I haven't done anything crazy. But now what I do is I factor by grouping. Group the first two terms together and group the second two terms together. In the first two terms, I have 2x squared minus 4x. Well, I see a 2x in common. When I see a 2x in common, 2x squared divided by 2x would just be an x. Minus 4x divided by 2x would be a -2. In the second two terms, I have a 3 in common, but anytime you have a negative leading coefficient, you always want to factor out a negative. So I'm actually going to factor out a -3. Let's be careful with this. -3x divided by -3 is an x. Be very careful with this. 6 divided by -3 is actually a -2. So what this factors into is 2x times x minus 2 minus 3 times x minus 2. Well, if you notice, both of these have an x minus 2 in common, right? So we can actually factor that out. So it factors into x minus 2 times, well, what would be left in the first term if I took away the x minus 2? I'd have a 2x. In the second term, I'd have a -3 if I took out the x minus 2. So this should be the factored version of the original problem. Give it a try. X times 2x is 2x squared. Then I'd have a -3x. I'd have a -4x, which is my -7x, and I'd have plus 6. So indeed, I did factor this properly. If I factored this properly, now I could take each factor, x minus 2 equal to 0, which would give me x equals 2. And I could take 2x minus 3, set it equal to 0. Add 3 to both sides, I'd have 2x equals 3. divide both sides by 2, and I'd have x equals 3/2. If you notice, I get the exact same answers as I did using the quadratic formula. Moral of the story, quadratic formula is probably easier on this one. Totally up to you. I don't care which method you use. There's actually another method that I showed in the solutions. That's called the cheating method. I don't care what method you use to factor. You just need to be able to get those answers, okay? Whatever's fastest and most accurate for you on the test is what I want you to use. So let's go on to D here. D here, let's think about if well, it's not a leading coefficient of 1. There's a 4 there. So again, we could try AC factoring method. We could try the quadratic formula. Totally up to you. I will let you know that if you tried the AC factoring method, you need two numbers that multiply to be 4. Those same two numbers need to add to be 6. Those numbers don't exist, so that means there's no simple, nice answer solutions to this problem. Rational numbers, they're going to be irrational numbers. Irrational meaning we're going to have a square root of a number that doesn't simplify. Like, it's not going to be like the square root of 9. It's going to be something like the square root of, 5, a number that doesn't simplify. So anytime I see that, I'm just going to go ahead and use the quadratic formula. Again, let me write down A equals 4, B equals 6, and C equals 1. I'll remind you of the quadratic formula. It's negative b plus or minus the square root of b squared minus 4ac all over 2a. I'm going to go ahead and plug in those numbers now. So I know x equals, this would be negative b would be a negative 6, plus or minus the square root of b is 6 squared minus 4 times a, which is 4, times c, which is 1, all over 2 times a, which is 4. Go ahead and simplify that out. And I'd have x equals, well, look, I'm not gonna beat around the bush here. Why do this by hand? Why do this step by step when our calculator can do it for us, okay? Our calculator reduces radicals for us. Our calculator does everything for us. So just go ahead and throw this into the calculator and see what you get. There are some things that I'm gonna want you to do different than your calculator, but let's put it into our calculator and see what we get. So when I put it into the calculator, what I'm getting is the square root of 5 minus 3 all over 4 is the first one. And then I get the square root of, negative the square root of 5 minus 3 over 4 is the second one. That is a little weird that our calculator puts the radical first. What you would have seen if we separated and simplified is we would have said negative 3 plus root 5 all over 4 if we simplified it, and negative 3 minus root 5 over 4 if we simplified. Again, another way that we could write those, and in the way that I actually prefer it, is separating it because we have a single denominator. So this would be negative 3/4 plus root 5 over 4, and then negative 3/4 minus root 5 over 4. So these are the numbers that I personally would have written down if I were to write the answers on that. But I'm not going to lie, I would have accepted any of these answers. Likewise, so would have your digital homework system. So either of those answers would have been fine. I'll just go with the first one because that's what our calculator would have given us directly. So again, if your leading coefficient's not a 1, sometimes you can factor and you're going to have nice rational solutions. Rational, again, meaning fractions. Sometimes you're going to have horrible, ugly, irrational solutions. Again, irrational meaning it can't be written as a fraction. This is when you have things like the square root of 5 or the square root of 3 or 2. Okay, let's move on. It says solve the following quadratic equations. There is no difference between solving a quadratic equation and finding the zeros. They're absolutely the same thing, the same strategy. So here you just set it equal to 0 and you solve. Again, here we need two numbers that multiply. So we have x squared minus 2x minus 8 equals 0. We need two numbers that multiply to be negative 8. Those same two numbers need to add to be negative 2. Those numbers would be what? Negative 4 and 2 look like it works. So this would factor into an x minus 4 times an x plus 2. Set each one of those factors equal to 0. X minus 4 equals 0. X plus 2 equals 0. I'm going to add 4 to both sides. I get x equals 4. Subtract 2 from both sides and I get x equals negative 2. So there would be my two answers, negative 2 and 4. Those would be the solutions to the quadratic equation. Beautiful thing is I can plug these back into the original. Just use your calculator, plug these numbers back into the original equation. So for instance, negative 2 squared is 4. Negative 2 times negative 2 is 4. 4 plus 4 is 8. 8 minus 8 is 0. So indeed, this is a solution to the quadratic equation. We could do the same thing with the number 4, plug it into the equation, and we would get 0 as well. So let's continue on. How about x squared minus 4 equals 0? I'm going to show you one of the biggest mistakes that I see all the time when solving this equation. I see a lot of students add 4 to both sides, and they get x squared equals 4. That is mathematically accurate. Since it's a square, to get rid of it, they square root it, and so they say x equals, well, the square root of 4 is 2, and they get the answer 2. There's a huge error with that. What you need to remember always is anytime you take the square root of a square, you actually have two answers, plus and minus. So you'd have plus and minus 2. Never write plus and minus on a final answer, though. Always separate them as two separate answers. So when you take the square root of a square, you have to remember plus or minus. If you forget the minus and you only do the positive version of it, you are going to miss several problems in this class. So what's a fail-safe way of doing this if you don't want to forget the plus and minus? Well, it would always be to factor. Look at this original problem. X squared minus 4 is the difference of squares. That would factor into x plus 2 and x minus 2 equals 0 because it's a difference of squares. Go ahead and verify that. You need two numbers that multiply to be negative 4 and add to be 0. Those are your two numbers. Then you could set each one of the factors equal to 0. And when you set each one of the factors equal to 0, you have x plus 2 equals 0. Subtract 2, you get negative 2. You have x minus 2 equals 0. Add 2, and you get x equals positive 2. You're getting the exact same two answers. So, faster way is add 4, square root both sides. Slower way is probably factoring. But what's more accurate on the test? Almost always the students who factor will get it right. But I would say about half the time, the students who take the square root forget that dang negative and miss one of the answers. So either way, you're getting credit on the test. Do it how you want. Just be careful. Make sure you have two answers on that one. Okay. Let's look at C down here. Looking at C, we have a quadratic equation. How do I know it's quadratic? Quadratic means you have a square term, so as your highest power. So we have 2x squared here. We have an equal sign. We have a quadratic. We have an equation. So what I'm going to do is set it equal to 0. So I'm going to add 5x to both sides. I'm also going to subtract 12 from both sides. So when I do that, I end up with 2x squared plus 5x minus 12 equals 0. Again, tons of different ways that I can do this problem. Totally up to you. Do you want to factor? Do you want to use the quadratic formula? Truly, I don't care what you do. Just to continue doing what I have been doing, I'll do the quadratic formula on this one. Looks like on the solutions I posted, I actually did factoring, but it doesn't matter. X equals negative b, so that would be negative 5, plus or minus the square root of b squared, so that would be 5 squared, minus 4 times a, which would be 2, times c, which would be negative 12, all over 2 times a, which is a 2. So this is, well, look again, don't beat around the bush, just throw this straight into your calculator, let the calculator do your work. Put both answers into your calculator, check what you get, double check my math. I'm getting negative 4 and 3/2. How do I know those answers are right, or how do I know if those answers are right? Again, all you have to do is plug in the equation, or plug in the answers into the original equation. So the answer was a negative 4. I'd plug in negative 4 to the left-hand side, get a number. Negative 4 squared is 16. 16 times 2 is 32. Plug in negative 4 to the right-hand side of the equation. Negative 4 times negative 5 is a positive 20. Positive 20 plus 12 is a 32. So on the left, I'd have a 32. On the right, I'd have a 32. Negative 4 is a proper solution. I could do the exact same thing with 3/2. 3/2 I'd plug in over here, 3/2 I'd plug in over here, and I'd verify that I got the same value on both sides. So, always double check your answers. Anytime you're solving an equation, anytime you're factoring, double check your answers, spend that time. Let's look at D. D is x squared equals negative 3x plus 8. Again, quadratic equation because it's a square and an equal sign. I'm going to add 3x to both sides. I'm going to subtract 8 from both sides. So plus 3x minus 8 from both sides. I'd end up with x squared plus 3x minus 8 equals 0. On this one, because it's a leading coefficient of 1, I'm at least going to explore, can I factor? So are there two numbers that multiply to be negative 8 and add to be 3? Well, factors of 8 are 1 and 8 and 2 and 4. None of those can make a 3, so it looks like no numbers would work. If no numbers work for factoring, I'm going to go straight to the quadratic formula. Negative b would be a negative 3, plus or minus the square root of b squared would be 3 squared, minus 4 times a, the leading coefficient is a 1, times c, which would be a negative 8. Be very careful with your negatives there. Always put them in parentheses. All over 2 times a, which is a 1 in this case. Straight up use your calculator. Don't be ashamed. See what your calculator is going to give you. In this case, my calculator is giving me the square root of 41 minus 3 all over 2. And I'm also getting negative square root of 41 minus 3 all over 2. Please, please, please double check your answers. Double check my math. I do make errors. It does happen. Teachers make errors too. So please double check it. Again, we could double check our answer by plugging it into both sides of the equation. We should get the same value on both sides of the equation.